Just as people like to have fractions often reduced to lowest terms, for example, instead of leaving a solution as 2/4, people might reduce it to 1/2. People often like to take fractions that have square roots in the denominator and simplify them by doing what we call rationalizing the denominator. Let's look, for example, at 5 over the square root of 2. Here we have a square root in our denominator, the square root of 2. To find an equivalent expression that does not have a square root in the denominator, we're going to multiply by the square root of 2 on the top and the bottom of this fraction. When we do this, in the numerator, 5 times the square root of 2 is just 5 square root of 2. In the denominator, the square root of 2 times the square root of 2 is the square root of 4, and then the square root of 4 is 2. So we end up with 5 times the square root of 2 over 2. Now we don't have a square root in the denominator anymore. We do have one in the numerator, but that's okay. That's in many cases considered to be not so bad. The goal here is to do what's called rationalizing the denominator, starting with a fraction with a square root on the bottom and coming up with an equivalent fraction that does not have a square root in the denominator. Now, one time-saving trick is to remember that multiplying a square root by itself, you just end up with what was under the root. For example, when we multiply the square root of 2 times the square root of 2, we just get 2. We don't need to do that middle step of writing it out as the square root of 4 if we remember that shortcut. For example, if we start with 7 over the square root of 3 and we want to rationalize the denominator, whatever square root you're trying to get rid of on the bottom, you multiply by that square root on the bottom and on the top. We have to multiply the numerator and denominator by the same thing to maintain the value of the original fraction. Now in the numerator, all we would have is 7 times the square root of 3. Thinking of that shortcut we were just talking about, the square root of 3 times the square root of 3, we get 3. When you multiply a square root by itself, you just end up with whatever was under the root. Or if we look at 10x over the square root of 6, here the square root we want to get rid of is the square root of 6. So we multiply by the square root of 6 on the top and the bottom. In the numerator, we would have 10x square root of 6. In the denominator, the square root of 6 times the square root of 6 is 6. Now, unlike our previous examples here, after we get rid of the square root in the bottom, we end up with a fraction that we can reduce. 10 and 6 are both divisible by 2. So we divide them both by 2. 10 divided by 2 is 5. 6 divided by 2 is 3. And the rest of our numerator stays just the way it is. So we end up with 5x square root of 6 over 3. Notice that to be able to reduce a fraction after you've rationalized the denominator, you focus on the parts that are not under the roots. For example, in our answer here, we have a 6 under the square root and we have a 3 in the denominator. You can't reduce a fraction by canceling out factors where one of the factors is under root and one's not. In other words, to summarize, when you're trying to reduce a fraction, focus on the parts that are not under the roots and only worry about reducing those. If you'd like to try the next problem on your own, pause the video now and resume when you're ready to see the solution. Here we have 12 over the square root of 15. We want to get rid of that square root of 15 in the denominator, so we multiply the numerator and denominator by the square root of 15. This leaves us with 12 square root of 15 on the top. And thinking of our shortcut, the square root of 15 times the square root of 15 is 15 on the bottom. Focusing on the parts that are not under the root, 12 over 15 we could reduce by dividing both of those parts by 3. And we end up with 4 square root of 15 over 5.